Dear students, today we start our Fundamental of Digital Electronics, semester first. The subject is Fundamentals of Digital Electronics. In last lecture, we discussed about the basic logic gates, types of the logic gates, and the some operations related with the switches and its operations. Now, in these chapters, Unit 2 is called as the binary logic and Boolean algebra. So, in our GTU syllabus or curriculum, we here is a start our chapter number 2 is the binary logic and Boolean algebra. Its teaching hours is 8 and its total mark is 12. So dear students, in these chapters we have a different topic of binary logic and the Boolean algebra. So in that subject or in that chapter we are start with the logic gates. Before we start the logic gate in a depth, first we have to discuss about the logic. What is the meaning of logic? So if condition of the statement is satisfied, then our logic or thinking was true. So otherwise not satisfied or false. So our condition must be satisfied, then and then it will be say is a true or false or on or off. So explain with the example of switch, bulb and its operation, then how to control the bulb by using the switch. So here I see the circuit diagram. Here in circuit diagram we are taking a bulb, battery and the switch. Now switch is the controlling factor and this switch will be decided the bulb is on or off. In also we are having a line diagram of battery, bulb and the switch. So now here is the two state of the switch. How we can say this the two state of switch? Because switch is either they are on or off condition. Now switch is closed. At that time the circuit will be closed and the bulb will be on. And same way the switch is open when bulb is off. So now on switch has a two possibility. On it means logic 1 and off it means logic 0. Now if we use instead of one switch, we are using a two switch and check the controlling of the circuit, then we have switch 1 as a logic is a 0 and 1. Same way switch is suppose 2, it means S2 is a logic is 2, 0 and 1. So this combinations means total combination by using with these two switch S1 and S2 is a 4. It means like 0, 0, 0, 1, 1, 0 and 1, 1. So these are four combinations we have to check. The output is what happened in a circuitry. So here suppose the input is S1 and S2. So combination is 0, 0, 0, 1, is 1, 0 and 1, 1. So every student must be remember this is sequence is 0, 0, 0, 1, 1, 0 and 1, 1 for this particular subject. So everyone must be remember these four sequence and four combinations for the two switches or two input. So at that this is called as the four possibility of our inputs. So these four possibilities, it means it is a two variable as an input. It means the output will be either 0 or 1. So this will be checked by using the logic gates. So our input is S1 and S2 and output is either there Y is called 0 or 1 as shown in the diagram. So number of possibility of input is derived by using the formula is 2 raised to n. So n is number of variables or input. So if our input is 3 switch, it means the possibility logic will be 8. 2 raised to 3 it means 8. So this will be combination is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 111. So these 8 possibility we can check with our logic circuit. So the number of input will decide the number of possibilities and these possibilities will be checked by the using the logic gates. So I hope you understand. Now is the logic gate circuit. It means it's called black box. Is a square black box having a various inputs. So here I show the various inputs and output is only 1. So this is the basic fundamentals of logic gate circuit. Here is the 1 or 1 more than 1 is the input, output always 1. So we will check output always 1, either 0 or 1 and what will be happen? It will be checked. So logic gates are the circuit that take one or more input signals and send out a signal. Output is 1. So now we start with the list and explain the working of the logic gates. So logic gate is an elementary building the blocks of a digital circuit. So most logic gates have 2 input and 1 output. So any given moment, every terminal is a one of the 2 binary condition, low or high, it means 0 or 1, represented by the different voltage level. The logic state of the terminal can and generally does change often as the circuit processing the data. So in most logic gate, the low state is approximately 0 volt, it means 0 logic, and 5 volt, it means the 1 logic. So there are 7 types of logics. Now we are going to be discussed one by one. Before that, we have to discuss the various types of logic. It's as shown in diagram. The types of logic is the basic logic gates and the derived logic gates. The basic logic gates are the 3 types. It's the NOT gate, AND gate, and OR gate. And derived logic gate is called as a universal gate and arithmetic gate. And universal gate is further divided into NAND gate and NOR gate. And same way arithmetic gate will be divided into XOR gate or XNOR gate. So broadly classified the logic gates in 3 categories: basic gate, arithmetic gate, and universal gate. So this will be discussed earlier in a previous lecture about the types of gate. Here with representation of the gates, how we can represent the gates, it will be by rules which will be followed to define the each and every gates. So there are 3 equally powerful techniques or powerful methods to be described to represent the behavior of the logic gates and its circuit. The first one is the Boolean expression. So everyone first find out what is the Boolean expressions for the particular gate, then after it's truth tables, and third one is the logic diagram. So these 3 sequence must be followed for any gate to be represented. So Boolean algebra. The first we start from the Boolean algebra. So this Boolean algebra will be expressed in this algebraic notation. So this algebraic notation is the powerful way to demonstrate the activity of the electrical circuit. So this electrical circuit will be maybe AND. So this is AND gate is denoted by the dot, and OR gate it will be denoted by the plus, and NOT gate is denoted by the quoted mark or to be over bar, and XOR gate will be the plus circle. So these are the 4 methods to be denoting of the Boolean algebra expression. Then second is the truth table. Now truth table is depends on the numbers of inputs. So as previously we discussed, the number of input is increased, the possibilities of the input will be decreased. So truth table defines the function of a gate by listing all possible inputs combination that a gate could encounter and the corresponding output. So suppose the variable is 2, it means input is 2. At that time our input here is the A and B. So we have the combination is 2 raised to 2 means 4, it means 0 0, 0 1, 1 0 and 1 1. So this all 4 possibility we have to check what is the value of y. So this is making a truth table for the 2 variable. Now suppose for the 3 variable. So here earlier we discussed as the A, B and C. These 3 is the input variables or the input, and at that time the combination having a 8, 2 raised to 3 means 8. So this 0 0 1 2 1 1 1. So this 8 possibility check and note down in the truth table as a y as output, and it will be work on. And third one is the logic diagram. So our 7 gates having a different logic diagrams. So logic diagram is a graphical representations of the circuit, and each type of gate is represented by a specific graphical symbol. So these are the symbols as shown in figure: AND, NAND, OR, NOR, NOT, XOR and XNOR. So these 7 will be discussed one by one. So let's start with the basic gates NOT, AND and OR one by one. So we have in this lecture only discuss about the basic gates. So let's start with the NOT gate. Now NOT gate is also known as the inverter gate, and this is only the gate having a single input. So this symbol is like A is an output is a bar. Its the Boolean expression is y is equal to a bar or a dash. So is truth table is a single input, it means 2 raised to 1, it means 2 possibility. So here is the input is A, is a 2 possibility is the 0 and 1. So at that time it is just invert the input. Those input is 0, then it will be converted into 1, or 1 it will convert it into 0 as shown in the truth table. Now what the here 0 and 1 as input? So 0 it means maybe is the low and 1 is maybe is the high. If you suppose that 0 it means the slow, then 1 will be the fast. So these combinations of 2 possibilities, as same way it will be output also having a on and off in terms of logic 1 and 0. Here I show in terms of electric circuit, here A is the switch. This switch is a 2 possibility on and off. Here is the off condition, it's called 0, and on condition it means 1. So here is the switch closed and apply voltage is given. So at that time bulb will be on. It means the 0 will be available. At that time it will be available is a 1 and 1 is available 0. So this is a combination or electrical circuit corresponding to the NOT gate. So the NOT gate is an electronic circuit that produces an inverted version of the input at its output. It is also known as an inverter. If the input variable is A and the inverter output is known as a NOT A, this is also shown as a bar or a dash. Okay, so this is the NOT gate. So you just simply remember, if our input is 0, then it will be converted in a 1, or low it means high, off it means on. So this is the main characteristics of the NOT gate. Now our second is the AND gate. So AND gate is it also known as a multiply gate. So its symbols and its Boolean expression as shown in figure. Here is the 2 input. In these chapters we are considering only limited up to the 2 input, not more than 2 input. So here is the input is suppose A and B, the output is Y. So its Boolean expression is a multiple gate, it means Y is equal to A dot B. So its truth table, it means our 2 input A and B, it means 4 possibility 0 0, 0 1, 1 0 and 1 1. So at that time it is a multiply with the 0 into 0, output will be 0. So 0 and 1, then it will be also 0, 1 and 0, it also creates a 0. When both input is high, then output is always high. So this is the condition we'll be getting from the AND gate. Same way we have to check with the electric circuit. I here take A and B as a switch in a series form. So A switch has a 2 combination 0 and 1, B is also having a 2 combination 0 and 1. These 2 switch are in series with the apply voltage and lamp. Suppose we apply voltage is given and both switches are open. So current cannot pass through the switch to lamp. So lamp is always not glow. So 0 0 it means 0. Now either or A or B will be closed, but circuit will be not connected. That's why it's also having a output is 0 and 1 1, it means both switch are closed. Then and then the circuit will be completed and current can flow and bulb will be on. So these are the main characteristics of AND gate is when and when, means if and only if 2 or more events are true, or if and only A and B having a high level or 1, then and then only the output will be available. So lamp will light only when the switch A and B are closed. It means A and B both is logic 1. So this is our AND gate. Okay. So now our last one, it means the OR gate. So OR gate, it is also known as the additional gate or addition gate. Its symbol as shown in figure, that Boolean expression here, addition, it means A plus B. So input is A and B, output Y is equal to A plus B. So we have checked same the 4 possibility as previously we discussed in AND gate. So here is A and B. So 0 0, the 0 plus 0 it means 0. So 0 plus 1, the second possibility is always 1, and 1 plus 0 is also having a 1, and 1 plus 1 not in the mathematical way is a 2, but in a logical way it is a 1. So this will be create output is a 0 1 1 1. So this will be explaining in the electrical circuit by using the two switch, apply voltage and the lamp. But here is the condition is that two switch are connected in parallel. So as shown in figure, the A and B are the two switch which having a two possibility, A and B. These are parallel, so either or path is available if any switch is connected. Suppose both switch is not connected as shown in figure, the current cannot pass through and lamp will be off. Now I will be close the switch A, so current will pass through A and lamp will on, so output is available is 1. If I connected B, then current will pass through B switch. So any of the one switch is closed, output always available. If both switch is connected, the either or path they will be selected. It means low resistive path will be selected and output always available in lamp is on. So OR gate operation describes even which gain occurs if at least one at other events are true. So here I call as the event because here I considering switch on and off. You can take any kinds of possibility for any kinds of events, maybe high, low, dark, bright, any kind of situation you can be justify with this using the gate. So switch is in parallel, lamp will light, and when A or B are closed, it means A or B will be logic 1. At then and then it will be available, output is a 1. Okay. So dear friends, these three gates called as the basic gates. Not, and OR. So everyone remember for the basic gates about this NOT gate is output 1 when input is 0. It's also called as inverter gate. Then AND gate, the output 1 when both input are 1. Then and then only the output is 1. And OR gate, output is 1 when any input is 1. Then and then output always 1. So I hope you understood about the basic logic gates, because this is the fundamental requirement of a gate to know about this all three gate. By using these three gates, we can create any situation or any kind of gate. That's why it's called basic gates. So from next lecture, we will start from our universal gate, the next topic. It will be NAND gate and NOR gate. Okay. Thank you very much. I hope you understand. We will meet soon in the next lecture. Thank you.